All right, good day everyone. This is Jason Straight with the CloudPass Virtual Group. Our presentation today is Cloud Data Warehousing in Azure, Azure Synapse, and Snowflake. And our presenter is Britton Gray. Before I hand things over to him, I'm just going to go through a few announcements here. And hopefully the background sounds don't get too loud here for me today. I've just got a different layout today, so you may hear some background sounds until the thing starts. So the first announcement here is the virtual group is brought to you by Microsoft. Microsoft Azure supports us, the Cloud Virtual Group, and helps to make sure that we can have consistent presentations week after week. If you are not yet a member of the virtual group, I do recommend doing so and becoming a member. That'll get you access to the group and a list of all the presentations, along with a newsletter that lets you know about any upcoming sessions. In regards to upcoming sessions, we got quite a few coming up. I know that we didn't have any for the last couple of weeks, but we do have 9 coming up over the next 5 weeks. So encourage everyone to check those out. Next week, we've got Jason Horner, which was just added to the schedule, along with on the 24th, we've got Sarita Garg, who's doing a presentation as well. If you are interested in presenting, I'm always looking for more presenters, so you can email me at cloud@pass.org or fill out the form for the call for our speakers. This virtual group is part of a number of virtual groups that that PASS helps to support. These cover different languages such as Global Chinese and Global Hebrew, or different aspects of folks' jobs like business intelligence and DBA fundamentals. If you have any questions throughout the session, please type them into the questions panel. At the end of the session, we'll go through whatever questions are out there and see if we can get answers to everyone. And with that, let's hand things over to Britton for our presentation today, Cloud Data Warehousing in Azure, Azure Synapse, and Snowflake. All right, now to make you a presenter. All right, you should have access now to.
Hold on just a second. Let me get my technical gremlins out of the way here and make sure that, and you are seeing my main screen, right?
Correct.
Okay, awesome. So welcome everybody this afternoon, and at least the time I'm in the Eastern US, to the session on Cloud Data Warehousing in Azure, an overview of Azure Synapse and Snowflake. So these are effectively the 2 major platforms for large-scale data warehousing that are available to you within Azure. So a little bit about me. So this is my Twitter handle, I Dream in SQL. I don't know, like maybe some of you, I've actually done this. It's an interesting experience, to say the least. I am currently the Director of Business Intelligence at Project Lead the Way up here. So we are in the United States a nonprofit organization. We develop STEM curriculum for PK through 12 students and help our schools to give our students the best experience they can out of that curriculum. It's very project-based, very interactive. Kids seem to love it. So it's a great mission that I get to be part of there. So here at PLTW, we actually use Snowflake. That decision was made by my boss before I arrived. So before there was an actual BI department, that was made by our CTO. That said, it's been a good product, and we'll go over that. I also am the proud owner of an MCSE in data management and analytics. So I've been with a Microsoft concentric consultancy before I joined PLTW. And so I've also implemented SQL DW and its old on-premises counterpart, PDW, and the giant machine that is in the loud server room. So all in all, when it comes to the two between each other, whatever. So that's me. Okay, a little bit of history on these two platforms. And we'll also include Amazon Redshift just because they'd be mad if we didn't. Redshift really started as an on-premise product called ParExcel back in about 2008. I actually got to be on one of the teams that implemented one of the first implementations of that. ParExcel was just like PDW, a multi-million-dollar MPP appliance on-premise. So if you had terabytes or or potentially petabytes of data, that's what you'd use. Redshift bought the intellectual property to that at some point in 2013 and adapted it somewhat for the cloud. Then it's undergone some very minor changes since then. Spectrum, which is effectively just Polybase for Redshift, didn't come along until 2017. And then back at the end of last year, they've announced some stuff that supposedly makes it faster, better. One of the big things about Redshift is it is what we call shared nothing architecture. So you have the machine itself, the machine has certain processing power, and it has certain storage capabilities. If you go past the storage capabilities, then you have to buy a bigger machine. If you need more processing power but don't have quite as much data, too bad, you still have to buy it all in one package. So with Azure, Azure started with PDW. So PDW was kind of an amalgamation of SQL Server and then technology that Microsoft purchased from a company called Datalegro in 2008. So Datalegro was originally effectively a PDW with Postgres rather than SQL Server. So PDW was born in 2010, again, a multi-million-dollar appliance. So if you had that sort of money for the cost of entry, then good for you. If you didn't, well, then you're just still stuck with plain old SQL Server. SQL Data Warehouse came in 2016. It was adapted from, shall we say, some of the lessons learned, I think, by Microsoft through PDW and some of the pain points that people were adapting. But it brought it to the cloud and also brought it as on-demand pricing. So now the cost of entry isn't millions of dollars. Gen 2 arrived in 2018 and is better, faster, stronger. And then back at the end of last year, Synapse was announced. So it's effectively SQL DW Plus. That said, a lot of the Plus is still, as we'll talk about later, is still in preview. So it's really hard to pin down what the final performance and cost and those sorts of things is going to be. Snowflake wasn't released until 2015, and notice that unlike Redshift and Azure Synapse, there was no on-premise version of it. It was designed for the cloud, and so it is a cloud-only solution. So its architecture really shows that. Data sharing, which is one of their big things, was in 2017. So think of just multi-tenancy, effectively on steroids. So if the owner of one set of data can basically say, I want this other account from this other corporation who I'm going to share this data with them. They use it when they query the data. It is on their dime, not yours, but you still get to say what data you share. Azure came on being in the middle of 2018. Originally, when it was released, it was for AWS only, and now GCP is available as well. So a little note from the original version of this, when we're talking about Synapse today, we're going to be talking about most of the what we call formerly SQL DW features. So it's effectively now what Microsoft calls SQL Analytics within Synapse. The rest of it, again, as I said, it's a little hard to pin down right now because it's in preview. So as far as what final performances and costs and whatnot are going to be are still up in the air. But the features that are still in preview are pretty cool, including Spark integration. But that said, the Spark integration is not Databricks. I wouldn't be surprised if that comes along eventually, but it is plain old Spark. Studio, so there's a Synapse Studio that really is supposed to be a one-stop shop for all of your data management analytics needs when it comes to the SQL DW platform. So the Spark integration, and then one of the nice things that's going to be awesome is on-demand query processing, and we'll get into that reason here in a little bit. So the architecture of Azure Synapse. So you've got, in a lot of MPPs, you're going to see this architecture where you've got a control node and then one or more compute nodes. So the one control node is your one entry point, and you get one compute size for the data warehouse. And the compute size is determined given the number and then the relative beefiness of each of these compute nodes. So one of the things that Gen 2 put in was intelligent caching on NVMe SSDs. So as data is gathered through user queries from these containers here, which are in blob storage, then the most used stuff is cached on these compute nodes, and then subsequent queries become faster, just like intelligent caching in any database. So again, so these 60 containers are, and that's no matter what your compute size is, all your data is still in 60 containers. Within each container, it effectively carries a partition of a column store table. So that said, that's column store by default. You can override that to row store if for some reason, say your table was relatively small, and there are some circumstances in which row stores are faster than column stores. That said, we are looking at 60 containers. And if you're aware, if you're not, I'll tell you that column stores in SQL Server are effectively done in 1 million row blocks. So given that, in order to be really an effective solution, you're probably looking at a fact table of at least 60 million rows, probably 100 million rows is a better option. If you're looking at anything smaller than that, you're probably going to want to still just keep with plain old Azure SQL database. While this is super fast, it's a lot more expensive, and it doesn't work as well with this fact tables below about 100 million rows. Full backups, so these are snapshot backups, they're full backups automatically every 8 hours. Those are kept for 7 days. And then you can also user-defined restore points. But that said, all those snapshot backups you are charged for as far as storage goes. With Snowflake, they have what they call a pod. So this is effectively the combination of these guys that go on the blob store. So the compute goes to the blob store, and then there's a metadata store. So it stores data in what is known as micro partitions. So while the Azure SQL Data Warehouse or Synapse stores are in million row blocks, the Snowflake the Snowflake scheme basically stores those in much smaller partitions. So one of the nice things about Snowflake is you can have multiple endpoints against the same data. So if I'm loading data, I may not need as large of a compute node as if I'm doing data science on something. Well, I can actually run the two at the same time and put this load against this, and then the data science load against this. And if I'm not loading data, I can just shut this one down and save money. Just like Azure SQL Data Warehouse, I can query my results, or I have got the intelligent SSD cache against blob storage, where Snowflake manages everything like that, just like Microsoft does in Synapse. One of the neat things, and I skipped over that, is the query results cache. So in the query results cache, if queries themselves are put against your data and the underlying data has not changed, the results of that query are cached. So the next time that query is executed, there is no work on either this SSD cache or the blob storage. It just returns the result set. That's super useful if you're putting, say, dashboards against your data, and that entry point to that dashboard is likely going to be the same query all the time, as may one or two drill downs or drill throughs. So when you can just query the results that have been cached, that typically comes back within about a half a second, no matter what the complexity of the underlying query is. So as far as pricing goes, one of the biggest components of pricing in a cloud data warehouse is going to be compute. So in the Azure DW world, and this is Gen 2, so they're called DWUs. So it goes up from 100 all the way to 10,000. 100 DWUs is $1.51 an hour. So it just goes up proportionally there. And as you need more, you can get it. However, when you resize a node, all queries have to stop on that node. The resizing takes a couple minutes and then you can restart it. So it's not quite as elastic, I guess, as it first sounds. In Snowflake, they do what they call t-shirt sizing. So it goes from an extra small, which is effectively one node, to doubling with every single, all the way to 4 extra large, which you're going to pay about $256 a credit hour for. Actually, now that I think about it, I think Azure SQL DW has gone to, they've got a 30,000 C now that'll run you about $450 an hour, or if you're interested, about $4 million a year. So, small cost if you want that. So here again, it's in credits. That said, the compute charges are calculated per second. So as long as you've got your warehouse on more than 1 minute, because everything is 1 minute minimum charge, as long as you have it going, and if you shut it down in 3 minutes, you're only charged for 3 minutes of usage. And those unused warehouses auto suspend. So if no queries are going against a warehouse for a defined amount of time, you can go anywhere from 5 minutes on. Effectively, the warehouse ceases to be, and the warehouse in Snowflake terms is effectively just your endpoint. When it suspends, you're not charged for it anymore, and but as the negative, you also lose all your caching. So there is a bit of a balance there. The SQL pool part of compute, because there is now on demand with Synapse. This is the $1.51 is most US regions. There are a couple of US regions that are a little bit less than that, about $1.21 an hour, I believe, per 100 DWUs. The international prices can vary widely, so I hope you don't have to keep your stuff in Switzerland because it's like more than twice as expensive. The compute time is charged in hour blocks. So if I've got a DW 1000 set up for 10 minutes and then I stop it, I'm still charged for an hour of usage. So that's important. If for some reason you take it up and put it down, that said, that's really not the use case for this. Unused warehouses do keep going until you manually suspend them. Storage. So storage for Snowflake, as you can tell, is a good bit cheaper than Azure. And as well, the big thing here is that Snowflake is billed fractionally in terabytes, so $23 a terabyte a month, where you buy Azure storage for SQL DW in 1 terabyte blocks. So if you go, as long as you're up to a terabyte, you're at $135 an hour. Don't know how they arrived at that magic number, but they did. So even if you've got, say, 0.2 gigabytes of data, you're still paying for a whole terabyte. Now, obviously, as you get toward petabyte scale, the effect of this is minimal, but for smaller to medium data warehouses, that's noticeable. So as far as SQL compatibility goes, Snowflake they consider themselves ANSI 92 compatible. That said, the original product engineers in Snowflake came from Oracle. So surprise, surprise, the extended syntax tends to be more like Oracle. Some of the things that might get you if you are used to SQL Server a lot more is that you need to quote any columns that have lowercase characters or spaces. So where you bracket things with spaces in SQL Server, that's about all you have to do. Where again, so this is not the same as this, or sorry, this is the same as this. This is not the same as this. So especially if you're staging data and you want to keep column names as they existed in your source data, definitely that's got to be kept in common. Some aggregations still don't work at window functions, so this is one of those cases where you can tell that it's still a work in development. I'm guessing they will fill in those holes eventually. The other thing is that you can't do an empty over clause in Snowflake. You have to give it just you'd have to put like an order by one or something like that in it. Even though it's junk, it won't take empty order by clauses. Empty window functions. So you can load data and then, you can parse data using JSON, XML, and delimited text functions, which are good for, again, if you're storing, say, results of web service calls or something like that in staging, that's immediately available. Stored procs, for some reason or another, are in JavaScript. So why, who knows, but other than the fact that maybe you get some more programmatic capability in JavaScript than you do in SQL, but it's honestly more of an annoyance than anything else. So Synapse is what they call DT-SQL, distributed T-SQL. We lovingly call it, especially in the PDW days, diminished T-SQL, as there are a lot of things you just can't do in it. That has gotten a lot better over time. So it's mostly a SQL Server syntax. That said, sometimes you'll get this lovely error message: functionality is not supported in this version. That's where the diminished comes in. You can't do joins and updates or delete statements, no recursive CTEs, and you can't do a CTE anything other than select. Like try convert and try cast have not been supported. And that's really, really maddening if you're processing huge data sets and have one issue within, say, a billion rows. That can definitely be irksome. It's got JSON parsing functions, but XML parsing, unlike on-premise SQL Server, is not supported. The user interface. So the native interface to Snowflake is web-based, and it's not awesome looking. I'll show that to you later. Supposedly a new one is in the works, but supposedly that new one has been in the works for, I don't know, at least 9 months. So it's coming soon, I've heard, for a long time. There is no autocomplete or code error detection in that native interface. Again, that's supposedly something that's coming. That said, if you really want to not use that interface, which I don't, you can hook up any of your generic JDBC database tools to it. There's one that we use, but it costs about $300 a year. So that's a negative. Where compared to Synapse, you can use SSMS, or you can use Visual Studio Community Edition, and it works lovely. There is Synapse Studio, which is in preview. It's going to be a one-stop analytics shop, all the way from data ingestion to querying to data science to, I believe, even Power BI integration. I have not been able to see it yet myself, but I hear it's pretty cool. So for those in the SQL Server world, obviously this is a huge plus, as there's minimal retraining involved. In the security world, you can use in Snowflake, you can use DB credentials, you can use an Active Directory provider, or you can use SAML. So for instance, we use Okta. It's single sign-on from there. Permissions, though, this is weird. They're granted only to roles. You cannot give permissions to a user. A user can have many roles, but again, unlike the SQL Server world, the SQL Synapse world, a user can only have one role at a time. So permissions are not additive. So if I give I can be, reader, I can be writer, I can be sysadmin, but I can't be two of those at once. It can get really confusing sometimes when I'm trying to do something and it says you can't do it. It's not because I don't have permissions, because I'm the Uber administrator. It's just because I'm using the wrong role. That said, if you want to make things easy, especially on end users who are not going to understand this role thing, you're going to have to effectively create roles or a role hierarchy that involves just about any persona in an organization. That's proliferation, and it can be a little much to administrate. Snowflake encrypts the data using rotating keys of their own. So as far as data security goes, that's effectively like the transparent data encryption. In certain editions of that, if you're, say, a healthcare provider or something like that, you actually can provide your own keys to encrypt on as well, if you want to be super, super safe. So that's an option. In Synapse, again, it's just Azure AD or DB credentials. Administration, just like SQL Server. So a user just has additive permissions, and then transparent data encryption is available and supposedly enabled by default if your instance has been created after sometime in 2017. That said, I literally just created an instance about 2 hours ago, and I had to turn on TDE for it. So not sure what happened there. So as far as loading data, both of them have effectively a polybase. Well, in this case, it is polybase. In Snowflake, it's polybase-like. So effectively, you're going directly against blob storage and loading data in from there using external load statements that are then processed by all the worker nodes, and poof, you've got data in your data warehouse. That said, Snowflake does not support ADLS, so you're going to have to go blob storage only. They also have something called Snowpipe, which is used to ingest continuous data. So it is a proprietary thing. That said, there is a Kafka connector, so if you want to use more of your open source type stuff, that's available. As far as ETL tools, there are some popular ones. I won't list them. The Polybase has a few more limitations than your typical SQL Server, but not that many. One of the most interesting ones, though, is that your data has to be UTF or UT8F or UT816 encoded only. So anything that's encoded in ASCII, if there are any sort of extended characters, it's going to not like it very much. So that needs to be kept in mind. As far as ETL goes, you can the big recommendation from Microsoft is to use ELT to transform data. So you extract the data into your warehouse by default, and then you transform the data within the warehouse. And it's much faster than trying to actually use an ETL tool to transform the data within the tool, because it typically is going to be single-threaded, where nice thing about a massively parallel processing database is it massively parallel processes. Azure Stream Analytics supports, I believe, as a preview, up to 200 megabytes per second of data ingestion into your SQL data warehouse. So that's definitely a big option if you're wanting to stream data. That's a pretty beefy pipe. You can use Databricks or HD Insight to load data through Polybase. And then there's Data Factory, and there's also, as a last resort, if you really like your SSIS, there is an Azure SQL DW connector. The SQL DW connector, oddly enough, uses Polybase. So what it does in the background is it writes files to your blob storage, and then it uses Polybase to load them. But if you're wanting to keep a hold of your SSIS packages, this is definitely a good option. Now, as far as storing the data, so the distributions are, I did not finish this one. So the distributions are automatically determined. You can override the default settings in Enterprise Edition if you want. That said, I've never had to do so, and it distributes well. And then to talk to this, in Synapse, you really do need to think about architecture and how you distribute your data, and that's in order to prevent something that we call data movement. So as I talked about earlier, you've got data in 60 partitions within your data warehouse, and when you're doing joins between those tables, you want to minimize as much as possible any movement that you have to do between those two tables in order to make sure that the data you need to join is all within one partition. So it's not as much of an automatic thing, it's a roll your own type thing, and there are definitely architectural considerations to be made. So unique features I talked about earlier. As far as Snowflake, you've got data sharing. So it's effectively multi-tenancy to the next level. So it's multi-tenancy with you not paying for it. So the querier pays for the compute to query your data, and you can even charge your customers as well on top of that for that data if you so choose, as well as even more of an inducement to do that. If you use data sharing, for every 10 credits that your customer uses, you get 1 credit back. So they are very much pushing that functionality. There is a data marketplace as well. So I don't know if any of you guys remember back when Microsoft had their own data marketplace. I don't know if they have another one again. I know the original one shut down, but effectively you will be able to sell your data sets if they are worthy. That said, I've been told that Snowflake has got some legal stuff they've got to work out over that first, so that's why it's not completely there yet. So Synapse Analytics has workload importance, so it allows users to jump to the front of the line if possible. That's really a direct response to the multiple entry points that Snowflake has. So you can make some queries more important than others. In this case, with a workload importance, you can make some queries more important than others. Automatic data discovery and classification is pretty cool. So if you enable it on your warehouse, it will crawl through your data and figure out if you have potentially sensitive information involved in there. If there's PI, for instance, for GDPR purposes, you can be alerted to, hey, there's PI here. Which is very nice, rather than having to write your own stuff to traverse databases or, God forbid, do it manually, because as we all know, people put PI in very odd places. You can apply analytical models directly. So there are DT SQL commands that you can use to effectively just say, score my data now. That is really nice without having to use some sort of an external tool to query the data and then process it. And then the Spark integration, which is in preview for Synapse Analytics, is going to be very, very nice. So when your use case calls for more of an in-memory type situation, you've got the Spark integration immediately, and you can literally query the same data with your SQL and with your Spark. So, Emu. What happens if your ETL messes up? Well, if you're like me, that never ever happens, wink, wink. But in Snowflake, you have something called time travel. And time travel is at the table granularity. That said, you can go up to the schema, the database level, if you want. But there are commands where you can select, clone, and undrop to a point in history. So you can say select this from this table at 2 hours ago. So if for some reason something messes up on a table, you can effectively just go back in time and pretend it never happened without doing an explicit backup. So that's very nice. We've definitely used it a few times. So by default, and in the standard version, you can do so within the past day. In Enterprise, you have the ability to extend that to 90 days. You can control that again at the object level. That said, we realize, and I say we as Project Lead the Way, since we keep data on kids, that there are privacy law issues potentially with keeping data backups that are immediately available for that long. So you can choose to extend it to less than 90 days if you wish. That said, Snowflake also can restore another 7 days of any data, though it's Snowflake only that can do that, so you have to raise a support ticket for that. In SQL Data Warehouse, as I talked about earlier, they give restore points, but it is at the whole warehouse granularity. So if something messes up, you just got to go to what everything looked like the previous day and rerun everything from that point. The snapshots are taken automatically every 8 hours and kept for 7 days, and then you can keep up to 42 manual restore points as well, but you're going to pay that $135.17 per terabyte to keep all those backups. So if you've got a large amount of data, you can really explode your storage bill pretty quickly. So benchmarking. It's important. which one's better, which one's faster. So one of the big things it's done is TPCH, which is an industry standard benchmark. The data model is about 8 tables. It's in a quasi-analytical format, so think of it as a mix between a star schema and third normal form. There was, back in November 2018, a tech research firm called GigaOM, which ran tests on the cloud DW providers. Little asterisk here, sponsored by Microsoft. It used higher end settings on these 4 products. I'm not even going to get to Google BigQuery because it's honestly not very good. They used a 30 terabyte size, and then it's a suite of 22 queries against that. So here are the results from the Microsoft sponsored study, where obviously from a price performance perspective, hey, look, SQL Data Warehouse wins. If you are like me and a nerd and go and read the report, there are a couple other things about it that really kind of belies its slant. For instance, in the section on Snowflake, they talk about how Snowflake relies on caches to be faster, where SQL Data Warehouse does the exact same thing. So there's definitely, even if you read the text report, a bit of a slant. So I took this with a grain of salt. So with that, I decided to run my own benchmarks. So I have a fake data set, which I developed a couple of years ago. I've got a whole presentation on that may be available still at, say, the SQL Saturday Indy 2018 site, if for some reason you're interested. But given the fact that this data set was really made for MPPs, there's a whole thing to try to make that data distribution as realistic as possible, because as we talked about, when you distribute data among lots of partitions, that distribution matters, because you don't want it skewed. You want to make sure that you're not moving data around as much. So data distribution definitely matters. So this is an analytical schema, mostly star-based. There are a couple of there's a snowflake here and an odd snowflaking going on here. But it's about 16.8 billion fact rows. And then I ran benchmarks for the load query update on that. And I use smaller warehouse sizes because this is not me. Unfortunately, I have no unlimited amount of money. And because I was not sponsored by Microsoft or Snowflake, that comes out of my own dime. So the benchmark tests I did, so loading from a blob storage, I loaded these guys and benchmarked. The customer was just a CSV uncompressed. The purchase was a gzip compressed CSV. And then as well, tested an update from the customer to a zip stats table that I use in a later query. That said, I will note that I have had issues and others have had issues that I've talked to loading anything other than an uncompressed CSV with the 100 level of server. So if you're loading anything that is either compressed or in Parquet or Orc, you're going to want to go for at least a DW300, say. So queries, first one, it's pretty simple. I just wanted all customers in a certain zip code that just happens to be in Indiana, where I am. Next, there is getting effectively a top brand by state and the store state by month. So this becomes a little bit more complex, though we're still going directly within a star schema. Then we're getting the top 100 zip codes for customer sales per capita. So this per capita uses a zip stats. It says how many people are in the zip code. So we're suddenly snowflaking a little bit. And the queries continue to get a little more complex, or in my case, purposefully sadistic. So here we're getting a unique customer count binned by a customer's distance from the store. So each customer is coded with a lat long, the store is coded with a lat long, but for purposes of not wanting this query to take years, rather than doing the direct distance between the store and the customer, I just use a zip as a proxy to say if a customer's in one zip and a store's in one zip, what's the distance? So this group by is actually done from a material table rather than a calculation. And then last but not least, definitely not least, a seasonally adjusted best and worst sales months for each state for a specific product type. So this is having to do it in two passes. First of all, to do a total by date, and then to break it up by what we needed to, and then effectively use windowing functions to calculate a percentage. As far as the results go, one of the things that we will notice here, just especially for loading, Snowflake was definitely far faster, especially on the compressed purchase one, because I had to use a higher level in order to even get it to load. So as I use a higher level, obviously more money and the cost increases. So that was definitely a big one. But if we notice as the queries in our query here get more complex, that the price performance for this definitely goes toward about a 1-to-1. So what we can gather from that definitely is that Synapse is great for really complex data on larger queries, and that's where it really shines. And you get your bang for the buck, so to speak. Updates, roughly about the same performance. One thing I'll also note about this is that this is not a complete apples to apples comparison, as because the Azure pool is an always on thing, where where Snowflake's warehouses can be suspended and not suspended, or sized at will. I really would like to use Synapse's new query on demand to see exactly how this keeps in a price performance scenario. That said, right now, that on-demand pricing being in preview is a riddle wrapped in a mystery inside an enigma. So once we hopefully get a little bit more input or view into what that on-demand cost is, that'll be awesome. So effectively on demand, just being serverless querying. So you put the query to Azure, and it returns it, and you are charged not by a compute node, but you're charged by effectively terabytes processed in the query. So that's coming, and hopefully it'll be a lot more transparent, and I'll be able to figure out how this compares in a cost comparison to the current pool schema. So as far as what this all means. So Snowflake, I say it shines more with medium data. So that goes back to the benchmark results that we just saw, where definitely as your query complexity is a little bit lower, maybe as your data size is a little bit lower, it's a definite winner in price comparison over Azure. Especially also with the ability to suspend and auto spin it up again in, say, your smaller to medium enterprises that may be a little more data centric, but still not completely. You're not running a query load on it all the time. So if it's not being used, it just automatically goes off and doesn't cost you money. So that's why I say more with your medium load, your medium data. Let's see, the structure of Snowflake itself makes multi-tenancy easier if for some reason you are in a multi-tenant environment where you're effectively selling access to your data warehouse. Snowflake is also multi-cloud capable. So if you're on something other than Azure as well, this becomes a potential upside, as you can copy data between your Snowflake instances on different clouds if you need to. And then there's definitely better exception handling with Snowflake, as well as you've got the try-cast, try-convert, where Synapse is still a little mysterious in its errors. That said, Synapse is much better for large workloads on large data. It is a very, very fast product on petabyte scale data. So if you are a large organization crunching a large amount of data, this is going to be a really good option for you. It's also going to be a very expensive option. As I talked about earlier, it can run you at the highest levels just for compute, almost $4 million a year. The Spark and analytical model integration are going to be great reasons to go with Synapse once it probably is out of preview. The one-stop shop for all of your end-to-end analytics in one spot is definitely is going to be make your BI developers really, really happy. And then if you don't have the big data, again, as we talked about, the price of admission alone being about 100 million rows of data per fact table. If you don't have that, just go with Azure SQL DB. You can get a pretty good instance. You can get your clustered column stores and those sorts of things that still give great performance in a much less expensive, much less difficult to take care of package. So that still works great for a lot of analytical workloads. So with that, that's pretty much a wrap. I have a write-up on my benchmarking. Right now it is on the SQL Server SQL Saturday Indianapolis 2019 website. I'm sure that I could work with Jason to get a copy of that up for you guys as well, if you're interested. Other than that, are there any questions?
Yes, there's a couple questions. Britton, This has been great. So the first question is someone's wondering if you'll be able to share your slides.
Okay, so yes, I can definitely share them. Is there a spot for that to be uploaded to you?
If you just email it to me, I can attach it to the meeting archive.
Yep, sure. And it's not just the slides. I do have, if you're interested, I do have a complete write-up, very detailed on the benchmarking I did and why I did it, and literally what the results were per query and number of seconds and how that got calculated into that price performance ratio.
Oh yeah, that'd be great.
Yep.
The second question is there's a glaring omission of any XML support on the Microsoft side. Do you know much about this?
Well, I'm guessing that Microsoft's idea is that XML is old school and JSON's the thing. So they probably just didn't want to deal with the XML parsing. If you really want to XML parse, you're going to have to do it outside of SQL Data Warehouse. Why? I don't know, because we as part of my organization, some of the web services we get are still in XML, so I use XML parsing in my ELT within Snowflake, so it's definitely used. Yeah, but I would agree it is a bit of a glaring omission.
All right. What's your preferred tool for loading data?
My preferred tool for loading data is into Snowflake is Matillion. Matillion is great. That said, it runs about 250 or so an hour that it runs. So Matillion's nice because it's also cloud-based, and they charge by the hour rather than an upfront software cost. That said, there's a lot of things that we use Matillion for that we honestly don't have to. So I am starting to work on going serverless for loading. So using effectively Python on demand to just on schedules, just serverless stateless functions to do that instead. And we're hoping to save a good bit of money that way.
Okay. And then do you envision that there'll be any partnershiping between Snowflake and Synapse as complementary solutions, or should people just see them as pure competitors?
They're frenemies. So obviously Microsoft makes money off of the fact that there are Snowflake instances on Azure because they've got to pay for that compute, that storage, all that sort of stuff, and of course that's passed on to us, the users. That said, given the fact that a lot of what Synapse has done, not all of it by any means, but a lot of what Synapse has done in the past year or two seems to, at least to my outsider view, to be somewhat responses to Snowflake. I would guess that there's probably never going to be complete friendliness, shall we say.
Right.
That said, I do believe each one has its own use case. So where, like our organization, we're a smaller enterprise, that said, very data centric. So access patterns, being our stuff, Snowflake's perfect. But if you are, some giant corporation with, constant loads 24/7 against your data warehouse, that's a different story.
All right. And we got one more question. I think we just got just enough time for this one.
Okay.
Let's see. Our environment is heavily T-SQL stored procedure based. Would converting the T-SQL to wrap in a JavaScript code significantly impact the performance? And how easy is the conversion migration from T-SQL based code to run on Snowflake?
Okay. So there are definite differences in the two. I would, for obviously the more just SQL statementy your procedures are, I think the less time it's going to be to migrate that. In fact, I, being the nerd I am, have actually written some Python scripts to do a lot of that conversion automatically. So known differences, it just handles. The less pure SQL there is, I think the more it's going to be. As far as wrapping it in JavaScript for procedures, it's not that bad. I mean, literally, there's just a JavaScript command you put in. This is basically run SQL, and then you put in the SQL as a parameter for it. So it can be a bit of a pain when escaping stuff, but it's not awful. But that said, given where we're going serverless and whatnot, I'm honestly just effectively doing pseudo store procedures and having the code itself, the Python code, just says, I recognize this is a SQL statement. This is a SQL statement. I'm just going to run them in order as if it were a stored procedure. So it's again, I'm like, why don't you have SQL stored procedures as an option? It's definitely an annoyance, but I wouldn't call it much more than an annoyance. So it's not awful for sure to convert the two, but that said, if your developer time is pretty expensive compared to your other costs, it might be worth it to just keep it in the SQL world.
All right. Great. Well, that is all the time that we have for today. And I'd like to thank everyone for attending. Britton, thanks for this session here today. This has been great.
All right. Thank you. And yeah, I'll get that email to you as soon as possible so you guys can see the materials for yourself. And feel free to follow up with any questions. I'm on Twitter, LinkedIn, all that kind of good stuff. So.
All right. Excellent. Thank you. And everyone have a great day.
All right. Thank you.